Hello everyone. At this time, I'll introduce the conjugate zero theorem. And this theorem's proof is very simple. This proof requires 7 lemmas, like this. Lemma 1. Lemma 1 is conjugate of z plus w is equivalent to conjugate of z plus conjugate of w. Bar can be split by plus operation. And the second lemma is bar z minus w is bar z minus bar w. And the third lemma is bar of conjugate of z time of w is equivalent to bar of z times of bar of w. And the lemma 4, bar of z over w is equivalent to bar of z over bar of w. And the lemma 5 is application of lemma 3. Sorry. Bar of z nth power is equivalent to bar z nth power. And the lemma 6 is if z is a real number, then bar z and original of z are equivalent to each other. When z is a real number, then conjugate of z and z are equivalent to each other is lemma 6. And the lemma 7, if z is a pure imaginary number, for example 3i, like this, general analog of this number called as pure imaginary number. In other words, z is a pure imaginary number when real part of z is 0. Then if z is a pure imaginary number, then bar z is bar z equivalent to negative z. Then let's prove the conjugate theorem, zeroth theorem. Assumption of this theorem is if polynomial has a real coefficient and complex number z is a zero of px. Assumption of the theorem is assumption 1 is px has a real coefficient. This sentence means that all coefficient of or constant term are real numbers. And assumption 2 is z is a zero of p. This sentence means that p of z equivalent to 0. Then conclusion of this theorem is bar z is also a zero of polynomial p. This means that p of bar z can be 0. Let's start to prove. And let's augment the index number. Lemma 1, lemma 2, lemma 3, lemma 4, lemma 5, and 6, 7. P Z should be equivalent to 0 by assumption 2, sorry. Then this means a n times of z nth power plus a n minus 1 times of z n minus 1th power plus blah 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 plus a 1 z plus a 0 is equivalent to 0 because z is a 0 of polynomial p. Then this sentence is sentence equals to a n z n plus a n minus 1 z n minus 1 plus a n z plus a 0 is equivalent to bar of 0. This is always true. And a n z nth power conjugation of a n z nth power plus bar of a n minus 1 z n minus 1th power plus blah 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 bar of conjugate of a n z plus a bar of 0 is equivalent to 0 because its definition, because of its definition, and bar can be split into each terms by lemma 1. Lemma 1 can be applied n minus 1 times in this process. And a n z nth power is means a n multiplicated by z nth power. And by lemma 3, bar conjugate of bar of z times of w is equivalent to bar of z times n of bar of w. Then bar can be split by multiplication. And also lemma by 5, z nth power bar of z nth power is equivalent to z conjugate of z nth power of conjugate of z. Then this can be written as also like this, plus a n minus 1 bar of a n minus 1 and n minus 1th power of bar z plus blah 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 plus a bar of a n times of bar of z plus a bar of a 0 is equivalent to 0 by lemma 3 and 5. And all of an minus 1 and a1, a0 are real numbers by the assumption of this this theorem. Then a bar of an is should be equivalent to an, and bar of an minus 1 is equivalent to an minus 1. Bar of a1 is equivalent to a1, and bar of a0 is equivalent to a0, because all of them are real numbers. Then this statement can be written as also an, just an, and the bar can be omitted, times of bar of z and bar of z plus an minus 1 times of n minus 1 power of bar z, and so on. 1 times of bar of z plus a0, because a0 is a real number, then this constant term can be written as also a0 is 0. Then last sentence, left hand side of the last sentence means p of bar z, and the right hand side is 0. And this sentence means that, the last sentence means that bar of z is a 0 of polynomial p. By the last sentence, this theorem has been proved. Then by this theorem, let's solve the example 6. Let's read the question of example 6. Find the polynomial px of degree 3 that has integer coefficients and 0, 1 over 2, and 3 minus I. Then px, because px is a cubic polynomial, then this equation is a cubic equation. And one of solution of this equation is 1 over 2, and another solution of this polynomial is this equation is 3 minus I. Then by the conjugate theorem, conjugate 0 theorem, we can find the last solution of this polynomial, because 3 minus I is a 0 of this polynomial. Then bar of 3 minus I should be a 0 of this polynomial, and the bar of 3 minus I is 3 plus I by the definition of bar or conjugation. Then we can decide the all zeros of this polynomial. All of this polynomial is 1 over 2 by given and 3 minus I and bar of 3 minus I 3 plus I are the all zeros of this polynomial.